We'll start from chapter 27 today. I would want you to practice this with me. This phase is the theory phase. We have a calculation phase. That one is done on WhatsApp. You want to be part of our session. If this is your first time coming across any of our clip, I'm going to leave a link in the description box of this video, or you can request in the comment section, and I would send it to you directly. Next, first question here has to do with calculation. It's been solved already. Number 2, calculation. 3, calculation. This series has a whole lot of questions that are calculation. Number 4, every house supplied with electricity is provided with a box of fuses so that the total current drawn from the remains can be limited. Option number 4, the total current that will be drawn from the main pole wire, you understand, can be limited. May not come over before you come burn things on a place or on a house. Calculation. 8 is the next theory. I want us to jot some points down. Right, jot this down. Fuse. A fuse would always melt when a current above its predetermined value passes through it. When a current above its predetermined value passes through it. So if the predetermined value of the fuse is 6, or let's say 7 ampere, then 8 pass through it, it will melt. You just disconnect. High tension transmission means, number 8, high tension transmission means, right, high tension transmission means transmission of power at a low current and high voltage. Low current, high voltage, that's what they call high tension. We are going to see this question multiple times on this chapter. It's actually the most repeated question on this chapter 11. It is usual to transmit electric power at high voltage and low current. This is called high tension. Which of the following are possible advantage of this method? What are the advantage of this method? What are the advantage of this method? Right, let's see. Heat losses are reduced because the current are small. Roman figure I, which is option A. Heat losses will be reduced because the current is small. Then 12. Which of the following can be described as high tension transmission? High tension, high voltage and low current. High voltage and low current. Low current and high voltage. 12 is option B. You see, they repeat them again. That's like the most repeated question on this chapter. How do I know? By practice. That's why I also want you to, there's this level I also want you to be, where at least you can tell where this, you can predict an entire chapter. Say which of the following instrument consumes the highest current. There's going to be a little bit of solving there. Number 20, no solving. The function of a 5 ampere fuse included in a circuit supplying a household refrigerator with power is to keep the current supply below, to keep the current supply of the refrigerator below 5 ampere. Option B. Remember, the current must be below. If it is higher than what the predetermined value of the ampere, the fuse current is, it's going to melt. You can say our fuse don't burn, and because the current way they come past the current way our fuse fee collect. 22. Which of the following correctly represent the relationship between the temperature rise Q and current I in an experiment to illustrate the heating effect of the electric current? Number no option here. 23. Which of the following is an essential physical property of the wires used for making fuse? Low melting point. Low melting point. Option D. Low melting point. Remember, when the current is too high, it melts. Low melting point. 25. Electric power is transmitted at high voltage rather than low voltage because the amount of energy loss is reduced due to 25. Heat dissipation. Repeated question again. Calculation. 29. The heat produced in a conductor carrying an electric is, the heat produced in a conductor carrying an electric is inversely proportional to the current and the resistance. Inversely proportional to the current and the resistance. Remember, power equals IV. If you make current the subject, you get power over 29, right? Inversely proportional Sorry, the correct answer is option D. Heat equals I square I raised to the power of 2 RT. Heat equals to Heat is directly proportional to the square root of the current, resistance, and time. Option D. 29 is option D. 30 is not solved. The diagram below shows two similar bulbs X and Y. X and Y are bulb connected to a suitable power supply with F as an appropriate fuse rating. If the filament of X break, then what has happened? If the filament of X break, then what has happened? The brightness of Y will remain constant. The brightness of Y will remain constant. To the live wire. It's S. It's Q. It's P. Actually, the diagram was not indicated there. So run a bread toaster connected remain a steady current, power dissipated. 48. Electric appliances in homes are normally heated so that both the AC and the DC sources can be used. Option A. Uh, um, 50. Okay. A cell of internal resistance R is connected to an external resistor R. The condition for maximum power, that's 52. The condition for maximum power is the uppercase R or capital letter R equals to the capital letter small letter R. Option C. That's the condition. 53. Let's do a calculation. 54, 55, 56, 57, 59. Okay. Power supply is transmitted at a high voltage and low current. In order to, you see it again, they repeat it. 58. Increase power supply, prevent overheating. You do that to prevent overheating. Next question. You reduce the heat. In homes, electrical appliances and lamps are connected in parallel because parallel connection does not heat up the wires. I want you to jot this down. In series connection, the same current passes through all appliances, while in parallel connection, the current breaks up into smaller units. As dictated by the resistance of each appliance. So, this question, in homes, electrical appliances are connected in parallel because less current will be used. Less current will be used. This one calculation. The fuse is an electrical device. The fuse in an electrical device is always connected to the live side. Electrical device is always connected to option C, the live side of an electrical supply. Number 65. The maximum power transfer occurs in a cell when the external resistance is maximum power supply. Maximum power supply occurs in a cell when the external resistance is twice the internal resistance of the cell. PHCM measures its electrical energy in kilowatt per hour. It measures it in kilowatt per hour. I'm trying to check through the other questions here how to do with calculations. Electrical power 72. Electrical power is transmitted at high voltage rather than a low voltage because the amount of energy loss is reduced is because of the amount of energy loss is due to, I'll read this again. Electrical power is transmitted at high voltage. Remember, high voltage and low current is called uh, high tension. So electrical power is transmitted at high voltage rather than low voltage because the amount of energy loss is due to heat dissipation. Option A. Option A. 34. What is the total electrical energy consumed by using an electric? That one has to do with calculation, I think. That one has to do with calculation, and that's where we'll draw the curtain for this chapter. Quite short, and it has a lot of calculations. Please note, this phase is our phase A of the class for the theoretical aspect. This will help you build awareness and acquaintance with the questions, so at least you will know how the questions are set and being able to grab one or two notes. Once you are done with this, you snap and send to us on the WhatsApp group for assessment. Then we'll do some drills and we'll also take some tests there, and more explanations will be given to you there. If this is your first time coming across our item, the purpose of this video is to build awareness, like acquaintance. May you know how the questions take they come. The main sessions will be done on WhatsApp. I'm going to leave the link in the description box of this video. We run entrance exam classes and UTME classes, College of Nursing entrance examination classes. If you'd like to be part of us, make use of the link below to enroll. Thanks for watching.